At the edge of Russia's Pacific frontier lies a trench long believed to rival the Mariana for oceanic supremacy, a place crowned in textbooks as deeper than 10,000 meters. But what if the Kuril-Kamchatka's legendary depth is more myth than reality, a century-old record hiding errors that shaped our understanding of the deep? For decades, scientists, ships, and satellites have sought the true number. The consequences ripple far beyond curiosity. In a region shaped by subduction-driven earthquakes and tsunamis, getting this wrong can mean misunderstanding one of Earth's most dangerous tectonic engines. So how did one measurement capture the world's imagination? And what do the latest discoveries reveal about the truths still buried in the abyss? The Kuril-Kamchatka Trench stretches nearly 2,900 kilometers along the restless rim of the northwest Pacific. Off Russia's far east, it arcs from the cold waters near the Commander Islands, past the volcanic spine of Kamchatka, and then runs parallel to the Kuril Islands before merging with the Japan Trench near Hokkaido. This is not just a line on a map, it is a living scar where two worlds collide. Here, the immense Pacific Plate, moving at roughly 8 centimeters per year, plunges beneath the smaller Okhotsk Plate. The descent is relentless, driving the Pacific seafloor down into the mantle at a steep angle that grows sharper from north to south. This boundary is more than a meeting place. It is a conveyor belt for geological creation and destruction. As the Pacific Plate dives, it drags water-rich sediments deep into the earth, where pressure and heat squeeze out fluids. These fluids rise, lowering the melting point of the overlying mantle. The result is a chain of volcanoes, fiery peaks that dot Kamchatka and the Kuril Islands, each born from the deep engine below. The trench marks the front line of this process, a zone where the crust buckles, fractures, and sometimes snaps with catastrophic force. The subduction system here has been active since at least the late Cretaceous, shaping the landscape above and below the waves. Earthquakes are frequent, some strong enough to send shockwaves across the Pacific. The trench itself is not a static groove, it bends, deepens, and shifts as the plates grind past each other. Along its length, the seafloor drops sharply, sometimes plunging thousands of meters in a single step. Each segment of the trench tells a story of ancient collisions and ongoing tension. Yet for all its power, the trench remains a place of uncertainty. Its exact depth, its shifting floor, and the hazards it harbors are all woven into the fabric of this boundary. Understanding where the trench lies and why it exists is the first step toward grasping the risks and mysteries that still lurk in its shadows. In 1957, the Soviet research vessel Vityaz set out across the North Pacific, equipped with the era's best single-beam echo sounders and a mission to probe the planet's hidden depths. Near 47 degrees 30 minutes north and 155 degrees 21 minutes east, the Vityaz recorded a reading that would echo for decades, 10,542 meters. This single measurement, taken during the ship's 20th expedition, landed in the scientific literature as a New World contender. The site gained a name, Vityaz Deep, and its figure was soon repeated in encyclopedias, textbooks, and news reports. The allure of a record was irresistible. In the Cold War atmosphere, a Soviet ship discovering the deepest spot in the North Pacific made headlines. But beneath the excitement, the measurement rested on a narrow foundation. Navigation relied on celestial fixes and dead reckoning, with no satellites to confirm the ship's exact position. The echo sounder, though precise for its time, traced only a thin line across the sea floor, missing much of the complex topography below. As the years passed, the number 10,542 meters became more than just a data point. It was a headline, a badge of scientific achievement, and a fixture in reference books like Britannica. The name Vityaz Deep became shorthand for the trench's supposed maximum, even as oceanographers quietly debated its accuracy. Each retelling, each citation, pushed the figure further into the realm of accepted fact. Yet the story behind the number was rarely told. Few mentioned that the reading depended on corrections for water temperature, salinity, and sound speed, factors that could shift a depth by tens or even hundreds of meters. Fewer still acknowledged the challenge of pinpointing the deepest spot in a trench that runs for thousands of kilometers, with steep walls and narrow depressions that could easily be missed. The single number trap had taken hold. What began as a bold claim from a single Soviet voyage grew into a legend, repeated so often that even scientists struggled to question it. The mystery of the trench's true depth had only deepened, waiting for new eyes and new tools to test the myth. Don't forget to subscribe. Every deep-sea trench tells its story through numbers, but those numbers can drift, sometimes by hundreds of meters, depending on three technical culprits. The first is location. Trench floors are not smooth plains. They are riddled with steep-sided valleys and narrow depressions, some just a few kilometers wide. If a ship's track line misses the true deepest spot by even a small margin, the recorded depth can be off by a staggering amount. This is especially true in the Kuril-Kamchatka Trench, where the deepest point might lie hidden between survey lines, waiting for a lucky pass or a more systematic grid. The second culprit is the tool itself. Early expeditions relied on single-beam echo sounders, which sent sound pulses straight down and measured the return time. Each reading traced a single line across the sea floor, offering no information about what lay to the left or right. These instruments could not reveal the complex topography of a trench that twists and folds over thousands of meters. In contrast, modern multi-beam sonars sweep wide swathes, capturing a detailed map of the trench floor in 3 dimensions. The difference is profound. What once appeared as a single, sharp depression might, under closer scrutiny, resolve into a gentler slope or a cluster of smaller basins, none quite as deep as the old record suggested. The third factor is correction. Water is not a uniform medium. Its temperature, salinity, and pressure all affect how fast sound travels. Early soundings required careful adjustments based on surface measurements and broad estimates. Small errors in these corrections could shift a depth reading by tens or even hundreds of meters. Navigation added another layer of uncertainty. Before satellites, ships fixed their positions using celestial navigation or dead reckoning, sometimes drifting kilometers off course. The result is simple. A depth might be attributed to the wrong spot, or a record might be claimed where none existed. Together, these 3 factors, where you measure, how you measure, and how you correct, explain why the Kuril-Kamchatka Trench's depth has been so fiercely debated. Each new survey, each improvement in technology brings the numbers closer to reality. But with every advance, the legend of the deepest point faces a new test. The call for a decisive resurvey grew louder as scientists sought to settle the question once and for all, armed with instruments capable of capturing the true shape of the trench in unprecedented detail. In August 2016, the German research vessel Sonne set out to settle a question that had lingered for nearly 60 years. How deep does the Kuril-Kamchatka Trench truly go? The crew aboard the Sonne, using modern multi-beam sonar, mapped the seafloor in precise overlapping sweeps, a far cry from the single uncertain lines of mid-century expeditions. Their mission was clear: revisit the legendary site known as Vityaz Deep and put the old numbers to the test, to measure the depth. The team aboard the Sonne worked through rough weather and steep, unpredictable terrain. Each pass of the sonar revealed more detail, peeling back the myth of a perfectly smooth trench. Instead, the bottom showed a landscape of ridges, pockets, and narrow depressions, some only a few kilometers wide. The crew tracked their position with satellite navigation, eliminating the guesswork that once plagued ocean explorers. Every ping of the sonar returned a data point, building a 3-dimensional portrait of the trench floor, meter by meter. When the data were processed and checked, the result was unambiguous. The deepest point the Sonne could confirm lay at about 9,604 meters, almost exactly 1,000 meters shallower than the depth recorded by the Vityaz in 1957. The coordinates of the historic Vityaz Deep, so often cited in textbooks, did not match any extraordinary depression in the new survey. Instead, the multi-beam maps showed a gentler slope with no sign of the dramatic pit once thought to rival the Mariana. This finding was confirmation of a long-suspected revision. The implications rippled through the scientific community. The legendary 10,542-meter figure, repeated for decades, could not withstand the scrutiny of high-resolution mapping. The myth had grown from a single, uncertain measurement. Now, with the benefit of technology and systematic coverage, the trench's true shape came into focus. The expedition aboard the Sonne did not just correct a number, it rewrote the story of the Kuril-Kamchatka Trench, shifting it from the realm of record-breaking depths to one of precise, hard-won knowledge. For the crew, the result was both a revelation and a responsibility. Their findings confirmed what many oceanographers had suspected, that the deepest trenches are not static and that legends built on sparse data can persist long after the facts have changed. The Sonne's verdict was clear. The Kuril-Kamchatka Trench, once a contender for the deepest place on Earth, stands instead as a monument to the power of measurement and to the need for skepticism, even in the face of a headline number. Don't forget to subscribe. On the evening of November 4th, 1952, the ground beneath the Kamchatka Peninsula heaved without warning. Offshore, a rupture along the Kuril-Kamchatka Trench unleashed a magnitude 9 earthquake, one of the largest ever recorded. Within minutes, the seafloor snapped upward, driving a massive wall of water outward in all directions. The tsunami struck the Kuril Islands and Russia's Far East with devastating force. In Severokurilsk, waves as high as 18 meters swept away homes, schools, and entire neighborhoods. More than 1,700 people lost their lives, and the destruction rippled across the Pacific, with distant shores in Japan and Hawaii recording the arrival of the waves hours later. Communication lines failed, and news of the disaster traveled slowly, leaving coastal communities in the dark until the water had already receded. This was not a remote event. It was a warning written in water and stone. The Kuril-Kamchatka Trench is not just a line on a map, it is a source of sudden, violent change. The 1952 shock forced scientists and governments to confront the reality that the trench's quiet depths could send destruction across entire ocean basins. In the decades since, the memory of that night has shaped how risk is understood and managed along the Pacific Rim. Seismic monitoring networks grew more sophisticated. The Pacific Tsunami Warning Center, established just 3 years before the 1952 quake, began to expand its reach and speed. Over time, new technologies, satellite communications, real-time ocean buoys, and global seismic arrays have transformed the way warnings are issued and received. The aim is simple: to buy precious minutes for evacuation, to turn science into survival. Yet the trench remains restless. In recent years, powerful earthquakes have continued to shake the region, each one a reminder that the forces beneath the sea floor are still accumulating. The Kuril-Kamchatka boundary is a living system, and its next wake-up call could come at any time. For those who track its movements, every new tremor is a test of the systems built in the shadow of past disaster. The stakes are measured not just in numbers, but in lives and futures shaped by the trench's unpredictable power. Arc volcanoes rise from the sea in a line that mirrors the trench below, each one a testament to the forces at work beneath the crust. As the Pacific Plate slides under the Okhotsk Plate, water-rich minerals in the descending slab release fluids into the overlying mantle. This process lowers the melting point of the mantle rock, fueling the creation of magma. The result is a chain of more than 30 active volcanoes, from Kamchatka's Klyuchevskaya Sopka to the islands of the Kuril Arc. These peaks are visible reminders of the deep machinery that shapes the region, a system where the same subduction engine powers both the violence of earthquakes and the slow, persistent growth of volcanoes. While the volcanoes draw the eye, the trench itself has been the focus of a quieter rivalry. For decades, the idea that the Kuril-Kamchatka Trench could rival the Mariana Trench for the title of the world's deepest point captured imaginations. The number 10,542 meters became a fixture in textbooks and trivia, repeated long after new evidence called it into question. But the most thorough modern surveys, including work from the research vessel Sonne, have set the record straight. The maximum confirmed depth of the Kuril-Kamchatka Trench stands at 9,604 meters, significant, but still more than a kilometer shallower than Challenger Deep in the Mariana, which reaches close to 11,000 meters. The legend of the trench's world-beating depth turns out to be an artifact of early measurement, an echo from a time when technology could only offer a glimpse, not a map. Today, the Kuril-Kamchatka Trench holds its place as one of the planet's great geological features, not because it claims the deepest spot, but because it reveals how science moves forward. Each improvement in measurement brings us closer to the truth, and each myth that falls away leaves a clearer view of the forces that shape our world. The trench is not a record holder, but it remains a living boundary, one that links the fire of volcanoes above with the darkness of the abyss below. Sometimes the biggest depths aren't what we measure, but what we still don't know. Share your thoughts below. Subscribe for more deep sea mysteries and don't miss a single episode.